In this section, I give you an overview of the organometallic compounds of the main group metallic elements. The metal of the main group form metal carbon bonded compounds with the alkyl, or it can be a aryl group. So it's overall known as organometallic compound. So organometallic compound means the compound consists of carbon and metal bond. Okay, so Grignard reagent, it's one of the organometallic compound. The general formula, it is a RMgX. So how can you, okay, to prepare that RMgX? I take the R and X alkyl halide, which will be treated with the magnesium in presence of dry ether. What will happen? Undergoing the homolytic cleavage, okay, this single electron transfer. So here I have the single electron of the alkyl group as well as halide part. So in this single electron can be transferred into the our magnesium metal. What will happen? As a result, I got the RMgX. RMgX, I am going to get that. So what is the statement here I am giving? Grignard reagents are made through the addition of magnesium metal to alkyl halide. The halides can be a chloride, bromide and iodine. So these are all, it's a preferable. So it's slightly easier to make the Grignard from the iodide and bromide. So however, the magnesium is inserting itself between the carbon and the halide. So when we refer to as the Grignard reagent. So what is the purpose of using the Grignard reagents? Okay, so here in this R group act as a nucleophile. So whatever type of the R group will be present, it always exit in the form of nucleophile of the negative charge. So what is the reason? The carbon connectivity, the nature of the carbon attached with the RMgX. So in this R and Mg, so here I have the R group. For example, in this R group I have the methyl system. In this methyl system, the carbon connected through the magnesium and the halogen. Okay, so this particular carbon and magnesium, it is a covalent, but it is a polar. And what about the magnesium and halide? It is a ionic natures. So now here I have the carbon, it is a non-metallic of the p block elements. Magnesium, it is a metal. So obviously here it will form the partially positive charge and partially negative charge will be present on that. So now as a result, in this particular CH3, it exiting as the negative charge. So this negative charge always seeking the positive nature of the any element or sources which will be react and producing the hydrocarbon derivative. So now I have the methyl chloride. For example, I have the methyl chloride. So methyl chloride formula, here I have the CH3 and Cl. So here, what about our nature of the CX bond? This is our nature of the CX bond. So this particular bond is going to be breaked and added to the magnesium. So what type of Grignard reagent I am going to get that? Here I am going to get the methyl magnesium chloride. Methyl magnesium chloride, I am going to get that. So once I got the methyl magnesium chloride, I treated with the water molecule. Now what will happen? This methyl magnesium chloride, this particular area, it's totally act as a nucleophile. Okay, so this particular area act as a nucleophile. So this particular nucleophile is going to be attacked with the proton sources. Okay, if you take the Grignard reagent, you treat it with any source of proton like water or ammonia or alcohol, it will immediately give the hydrocarbon derivative, which means that alkane system. So that is a case why the Grignard reagent, okay, its anhydrous condition is required. For example, dry ether. So I want to make the Grignard reagent mean dry ether, it's a vital part. Okay, it's a main important role in order to make the Grignard reagent. So once I got the methyl magnesium chloride, I treated with the proton source of the water molecule. Now what will happen? Here in this entire area act as a nucleophile. So nucleophile of this negative charge abstract the proton from the water source. So as a result, what happened? I am going to get the methane system. I am going to get the methane system. So now what is the difference? What is the difference between that methyl chloride and last product? So here, what type of okay, R group will be present? That will be the major one. How? So once I have the alkyl halide, once I got the alkyl halide, which will be, I want to make the only the R group, means first I need to make with the RMGX Grignard reagent. After that I treated with water molecule. So this is the main product of the hydrocarbon derivative. This is the one of the shortcut. So now here I am showing the questions from the NCERT book 6.9 index question. Identify A, B, C, D, E, R and R dash in the following. So here I have the 1-bromo cyclohexane. I treated with the magnesium dry ether A. I am going to get. Once I got the A product, I treated with the water molecule. I got the B1. So what will be the process name? So this is the nature of the CX bond. So where is our nature of the CX bond? This is the carbon and this is the bromine. This is the nature of the CX bond. So it's going to be cleaved with that. Okay. So now what will happen? The single electron transfer towards the magnesium. So as a result, I'm going to get the A product like this. Cyclohexyl magnesium bromide. So it's one of the Grignard reagent type. So in this R group, what will be the nucleophile type? So this entire area hydrocarbon derivative act as a nucleophile. So as a result, okay, so I treated with the water molecule. This particular nucleophile, it's abstract the proton from the water molecule. As a result, it will form the cyclohexane derivative. I'm going to get that. Okay, so this is the B product. So what will be the next step? In next step, I have the alkyl bromide, I have the magnesium. So this is the nature of the CX bond. So I need to add with the magnesium. So I got the product of RMgBr. I am going to get that. So what will be the D2O? It's a hard water. What is a hard water? H2O, it's a distilled water or it's a usual water. So instead of the hydrogen, I replace with the isotope of the deuterium. I got the D2O. So D2O, it is a hard water. Okay. So H2O, how can you separate it? It can be separated into the form of ions form of the H plus and OH minus. Similarly, D2O can be separated in the form of D plus and OD minus. So now in this R group of the alkyl group, okay, this is the R group of the nucleophile, is going to be abstract the positive source of the D plus. As a result, I am going to get this product. So from this product, I can guess that what type of R group it is. The R group will be so this is the R group. So this is the R group. So this is the same particular R group only which will be present on this R group and in this R group. So what will be the initial one? The initial one, it can be a CH3, CH and CH3 and Br is going to get. So what is the name of the compound? It's a 2-bromo-butane system. So RBr means here I have the 2-bromo-propane system. The 2-bromo-propane system attached with the magnesium. This type of Grignard reagent, I am going to get that. CH3 magnesium and Br, I am going to get that. Okay. So now in this second process, I have the longest, okay, this type of carbon derivative 1 2 3 4. It's a 2 2 3 3 tetramethyl butane system. So this is the product. What will be the reactant over to here? In this reactant treated with the sodium in presence of ether. So this is the Woods reaction type. So what is the Woods reaction perspective? Whatever the R group will be present, that will be dimerase form. So dimerase form means I have the single carbon system, means I got the odd number of the electron, odd number of the carbon system. It's converted into the even number of the product. So here I have the odd number of the R group. Here I am got the dimerization of the product. So what would be the RX type here? So here I'm going to get the CH3 and CH3 and CH3 and halogen. I'm going to get that. Okay, so if I add with the magnesium, okay, I got the R group of tertiary butyl substitution of methyl and magnesium and halide. Okay, so this would be the D. Answer D. So once I treated with the D, treated with the hydrolysis process, what type of product I can expect? That I can expect the CH3. So this is the negative charge. Okay, this particular entire area act as a nucleophile. So this nucleophile abstract the proton from the water molecule. So as a result, I going to get the, this is the answer. So what will be the product? It's a 2-methyl propane system. Okay, thanks for watching.